Hello, we're going to be doing the physics elevator problem with an individual of a certain mass and the elevator acting against them. So in this case, we have a woman whose mass is 51 kilograms is standing in an elevator. A. If the elevator floor pushes up on her feet with a force of 408 newtons, what is the acceleration of the elevator? Now the woman has a mass of that going down, the elevator's force is that going up. So we're trying to find the acceleration. So the easiest possible way to get that would be to use force equals mass times acceleration, the formula. But first of all, we need the force. We need to know the total force of this entire system, this going down and that going up. And this is in newtons, that's good. This is not in newtons, so we need to fix that. So we gotta go 51 kilograms, and in order to turn that into newtons, we need to times that by gravity, which is 9.8 meters per second squared. And then you put that in your calculator, you get 499.8 newtons downward. So, and we need to find the total force of that, so that's going down, and we got 408 newtons pressing upward. So, in order to find out what the resulting force of that is, you would subtract them from one another. And once you do that, you get a negative 91.88 newtons going down. It's a negative. So, okay, so we have the force. Now we just need something else. We need to adjust this formula so that we can find out just A. I don't want all this. I don't like how this formula is written. So we gotta separate that A from everything. Do that by multiplying this thing, or dividing it rather. So you get force over mass equals acceleration. So we got that. I still don't like it. I'm gonna flip it on itself so that the A goes first. Get that out of here. So we have the formula. We got the stuff. You know, let's make it happen. So we gotta go acceleration equals 91, because that's the resulting force of everything. 91 newtons. And okay, there. That over the mass we know the woman has a mass of 51 kilograms. So it would be 51 kilograms. And when we put that in our calculator, do you know what we get? We get 1.8 meters per second squared, and that is the acceleration equals A. So we've done that. Now for part B. If the elevator maintains constant acceleration and is moving at 1.5 meters per second as it passes the 4th floor on its way down, what is its speed 4 seconds later? Now, upon analysis of this question, I have come to the conclusion that the best possible way of solving it is by using the first kinematic equation, which would be the velocity is equal to the initial velocity plus acceleration times time. Because we need to find what the velocity is. It asks what is the speed. So let's make it happen. Velocity equals the initial velocity that is 1.5. So 1.5, excellent handwriting, meters per second squared. No, just meters per second, no squared. So that plus acceleration, we found that in the previous problem. That would be the 1.8 meters per second squared. I'm not about to erase it because this program is poo-poo. Times 4 seconds. So now that we've got these hieroglyphics here, 1.5 meters per second plus 1.8 times 4 seconds. And once you've plugged everything in there, you get 8. Oh my word. Let me try that again. You get 8 0.7 meters per second. And that is how it's done. So, you know, Miss Nikki is falling down at 8.7 meters per second squared. I'm glad we figured that out. So that is how you solve this problem. Thank you and goodbye.